Hi everyone, today I'm going to show you a short analysis considering an op-amp circuit. This is a part of ECS 203 Basic Electrical Engineering. Okay, so this is our circuit and we also have a capacitor here. So we want to find a voltage across the capacitor and also a current across the capacitor as a time function. First, what do we know? We know that the voltage at node 2 is approximately equals to the voltage at node 3. These are the node 2 and here is the node 3. And as you can see, node 3 is connected to the ground, so both are approximately equals to 0. And when you see here, we see that node 1 and node 2 are the adjacent nodes, and as node 2 is approximately equals to 0, we know that V1 is just equals to Vc. Alright, next we know that I sub c is basically c dV by dt, and I sub R1, which is here, is just delta V by R1, and that is 0 minus V1 by R1, or basically just negative V1 by R1. Alright, so first we are going to find Vc. Let's take a look at node 1. We know that the current in will be equal to the current out, and that is I sub R1 equals to I sub C. We found out earlier that I sub R1 is basically negative V1 by R1, and I sub C is C dV by dt. We also know that V1 here is equals to Vc. So we substitute that in, we have negative Vc by R1 equals C dV by dt. Alright, so I'm just going to move from left to right. dt comes here by R1, and we have C down, and on the right side we have dVc by Vc. Next, we're just going to take the integral of both sides. So we have the integral of dVc by by Vc, which is equals to the negative of the integral of dt by R1c. Note here that further on I'm going to call R1c as a tau function. Alright, so taking the integral of that, we have a natural log of Vc equals to negative t by tau plus a constant k. We take anti-natural log, we have Vc basically equals to e to the power of negative t by tau plus k, and we can write that as e to the power of negative t by tau times e to the power of k. What next do we know? We know that at the initial condition we have our V sub c as a function of time. At the V sub naught be equals to 0, and that we substitute 0 in, we have e to the power of 0 times e to the power of k. Okay, so now basically we are going to have our answer here. We have V sub c as a function of time will be equals to V naught, or basically the voltage across the capacitor at the initial condition, time e to the power of negative t by tau, when our tau is just R1c. Okay, here we have our answer. So next we are going to find I sub c is a function of time. What do we know? up here we know that I sub c is basically just c dv by dt. So we just found out our vc, so let's substitute that in. We have c dv naught e to the power of t by tau by dt, and that is equals to c v naught negative 1 over tau times e to the power of negative t over tau. And as we know that our tau is basically just r1 times c, so we have cv naught by negative r1c times e to the power of negative t by tau. So our I sub c as a function of time is basically negative v naught by r1 times e to the power of negative t by tau. And there you have both our answers. Good luck.